with that, let me introduce Robert Phillips, who's going to lead us in the topic of making jigs and hand tools.
Got mine.
You don't need this.
So hello, everybody. Boy, I had to talk quietly. I was going to project, but I guess I don't have to do that. So good evening. I'm going to talk, as Gary said, about jigs and handmade tools. And based on the number that I saw, number of people I saw carrying them in, there's going to be a lot of discussion. I think a lot of you brought some examples, and I really appreciate that. It's going to be awesome. So my intent for this meeting is not so much like the other ones where we have somebody presenting up top and you just look at the slides and we talk about stuff. It's much more open discussion. If you have questions about something, if your jig that you brought meets the particular characteristic I'm talking about, volunteer, and I'm going to pause and say, does anybody have something that covers that area? So it should be a fairly open meeting tonight. So we got quite a bit of examples, and hopefully we get quite a few questions. So introduction tab or slide. So jigs can be a wide range of complex and simple. This right here is a jig that probably just about anybody has, maybe not this one, of course, but everybody's got a workbench, but a workbench basically is a jig. It's a work holding tool. You can put stuff on it to hold your material this way or down or in here and facing up or whatever. You can build things on it. It's essentially a very customizable, really complex and expensive sometimes jig. But at the same time, if you've got two pieces, if you're trying to use a vise like this, if you ever put a piece of wood in this side and clamped it in, you notice the vise racks. A simple trick for that is to take a piece of wood, that's the same size as what you're trying to put in here, put it here, and then screw another piece or tape or nail or whatever to this side, and then you can just sit it here on the bench. When you screw your vise in, it'll match, and the vise won't rack anymore. And then when you loosen it, it's not going to fall out, and you have to reach over and grab it. So just a really quick, simple jig. So you can either go from super complex to two pieces of wood and a little bit of glue or tape or a nail. So why do we use jigs? They have a lot of different uses, but primarily they're used to increase your precision, to increase how accurate something is, how accurate a cut is, or how accurate you're placing things together. They're used to make your work more efficient, so you can do something repeatedly over and over again, to make things more consistent, so you can have the same cut or the same size. And they increase your safety. You might have a jig that holds something but a bandsaw or with a router table, keeps your hands away from the dangerous bits, and they can increase your versatility as a woodworker. So to talk about precision, first one on here, just looking at some of the pictures on here, I know I've got on the left is a hole drilling guide that John Champion made. John, you want to talk quickly about that? The one on the left, which is that one, your shelf pin guide.
Oh, yeah. I made a set of shelves for my closet. I made a set of shelves for my closet, and I wanted it to be adjustable sets. So I took a piece of plywood and drilled a set of holes in it so I could match the same holes for every part of the cabinetry I built. So you can barely see it there, but those little holes are what those pins are, and I hope they're evenly spaced. But at least they're spaced from the same position from the bottom. I always reference the bottom edge of that when I went up the side of each side of the shelf and I drill those holes. And it's basically just the holes. I use the holes as a guide and just ran my drill through that.
Thank you. And then the other two pictures on here are from Cliff. Cliff Wood's hiding in the back, but I can see him back there. So Cliff brought or took pictures of, did you bring them or do you just don't want to talk about them? Okay, cool. The one in the middle is a pairing guide. And then the one on the right is a mortise guide. And it looks like you brought the mortise guide.
Okay, good enough. Right, so the pairing guide in the middle, that's not mine. I got that picture from the internet. Mine aren't that nice. But there are just some cases where you really need to use a chisel to pare something down. And if you need to do it more than once, it might be useful to spend some time and make yourself a guide. something that either, rides on the edge of a piece or clamps down onto the top of it, so that you can very easily get a repeatable angle off your chisel. The other one I brought is shamelessly stolen from Paul Sellers. So if you want more information, you can look up his guides on it. But it is a mortise guide. So it's about as simple as you can get. As previously mentioned, it's just 2 pieces of wood, in this case, nailed together. And if you need to do more than a few mortises, which most of the time you do if you're making a table or what have you, this you simply put up on the side of your piece, and ideally this would be a little taller than the one I have here in my hand, but that's the size the scrap was. And you can register your chisel up against the side of that, both the edge of it up against the side of it, to chop the mortise, and then to pare down the side smooth. You can register the back of it against the face there. And then once you have it forever. So if you're ever chopping a mortise that's that distance in from the edge of your piece, you just either clamp it to or put it in a vise along with your workpiece, and you're good to go.
Cool. Thank you very much. Anybody, excuse me, anybody else have an example of something that might fit in this? Want to talk about it or questions about it? Yes, sir. Larry does. Hold on a second, Larry.
My name is Larry Faulkner, and this is out of Woodsmith
This was
magazine and their show, and this makes mortises, and it's adjustable for width and side to side, and it's fairly easy to make. It doesn't cost a lot except for mainly the clamp and knobs, and it is real easy to make. And I brought the instructions for a couple of these, but I couldn't find everything on this one. I just found the front page and another page. But you just clamp it on anywhere you can and be able to fit your wood in there. And surprisingly, it works very well. You make it so that your router fits in between the guides, but the table itself moves, and then your guides, as far as side to side, you can adjust it to whatever mortise. And you just have to do a little bit of practice the first time and mark where you want your mortises to be. After that, if you're doing the same ones, it's real easy. You just set it right up. And so if anybody wants to look at it a little closer and see the picture and come over here and clamp it down, something down, and see how it works. But yeah, it works fantastic. And it's cheap, and you don't have to put a whole lot of money into it.
Thank you very much, Larry. Anybody else have an example of this, that? Oh, there you go. Go ahead, Mark.
So working on the same token of really minimal amount of wood and money, this is a 2x4 that I've in fact planed on basically eight angles here. So all of them are square all the way around. The top I don't care about because it's going to be used to clamp. It's the same thing. I use it for mortising. I do a hand working with my Japanese tools. Go ahead and try to pair the ends. This works great. You just go ahead, since it's planed, it's really square, sharp corners. You can put the corner right on the line and go ahead and mark right down.
That's awesome. Thank you. Jim?
I don't think there's a jig that will give you more precision and more use than a shoot board. So I have one here that I made, and it's different from most in that you can see it has a ramp on it. What that does is allow, as the plane comes across like so, you're spreading the wear on the iron as you move. So you have to sharpen less. There's a downside to it too, because if I've only got about 3/4 of an inch of plane available back here. So too much slope. The more slope you put on, the more you're gonna spread the wear, but the more you're gonna limit what it will use, what it will do for you. But if you want a board that is square this way, and this way, you can't find anything that will do a better job of it than this. It's a workout, but I'd much rather do this than go to the gym any day. So here's how it works. Oh, by the way, it's got a cleat back here, so it catches on the table, on the bench, or whatever. Can you, is the camera on it?
Yeah.
Okay. And sometimes I'll lean up against it, and I put this UHMW high molecular weight. I think it's polyurethane. Yeah. Polyethylene. I've got another one that's just 2 pieces of plywood. I put wax on it. Works just fine. I had this stuff. I thought I'd use it, try it out and see. It works great. But this is, if the plane's side is square to its sole and the iron is set parallel to the sole, that joint will be dead on every time. You can hold this up to the daylight, up to a light rather, and there's no light at all comes through that. That applies to any angle you want to put on it. We'll pass this around, feel the surface that this thing turns out. That's one thing. The second thing is, everybody know what winding sticks are? But for those of you who do not, when a board has wind, as you look down its length, like so, it does this. You can run it through a planer till the cows come home, and it'll come out thinner, but it'll still have a twist in it. The way you correct that for a large piece, if it's small enough, you can run it over the joiner and then the planer, take it out. But if it's a large piece, use winding sticks. This is a pair that I made. 2 pieces of maple with as straight a grain as I could get. And the idea is I put one on this end of the board and one on this end of the board. And I get over here and I sight down. Yeah. I get over here and I sight down, and if these surfaces are parallel, this surface and my dark line, then the board has no twist from end to end. It may have some twist here. So I'm going to move this down, look at it, move it back and forth, find the high spots, mark them with chalk, plane them off, check it again and again. But this one, the reason I wanted to show this is I got these 2 pieces the same size, as close as I could get them, and I cut a rabbet in here. That's about 1/8 of an inch deep and 1/2 an inch wide. And I glued in a piece of wingy, which is the black wood. And I made sure the top of the wingy was parallel to the bottom. That makes the winding sticks work. Then I screwed on another piece of maple up here to protect that black line from damage. I can take it off. If this thing were to warp, I can take it off and repair it, put it back on there. So that's number 2. The third item is, this is a spindle for a rocking chair. And I can barely see it, but there's a little dip right here and a little bump right on this side. There's a little bump. Those curves need to be faired. A lot of times you cannot see them, but you can feel them. So how do you get rid of it? You can sand it, but you got to put pressure in the high places to knock those down. And if you just do it with your fingers and sandpaper, you're going to sand the low places and the high places. You're just going to have a smooth bump. So if you put this in a vise to hold it, well, I don't need to do that. Let's do it like this. I got a piece of maple here that's flexible. I got another one that's a little thicker. It's not quite so flexible. I got a bunch of them. I got 6 or 8 of them. Little handles glued on with coarse sandpaper. I can sand like so and bend this, and I'll knock off the high places just like a plane does on something flat. Then when you get the curve faired, then you can sand it by hand and smooth it up. But these are, the cost of this is 0. Just resaw something off and make them as thick as you can that'll fit the curve you're working on. And then just glue these little handles on, and they can be just like this or half as size, whatever suits your fancy. But anyway, that's it.
Cool. Thank you very much, Jim. Those are completely new to me. Anybody else with something that talks about precision? I just want to point out the jigs don't do one thing. The shooting board adds to your precision, but it adds to consistency. It does ultrasting. Gary's got the box joint? No.
This is a slightly different type of mortising.
Gary.
Oops, sorry. Slightly different type of mortising jig from the one Larry showed. But basically you put the piece of wood, and this can slide in and out. You can lock it into a vise to set the piece of wood so that it's centered right under this elongated hole. And you put a bushing on your router so that fits this width, and then you can adjust this screw to set the length of the mortise that you want to make. Put a upcut spiral bit in the router, and basically just plug it into the hole and go back and forth, and it'll cut a mortise and just keep adjusting in the bit till you get the depth you want. But again, pretty simple.
Thank you very much. Keep this away from my mic. So next slide, I think. So in addition to precision, the jigs will also help with efficiency. The couple of things I got, one is a box joint jig. Did Gene bring the box joint jig? And then a crosscut sled. I think everybody probably knows what a crosscut sled is. Most of you hopefully have a crosscut or have made a crosscut sled. But we'll have Gene talk about the box joint jig first.
Most of you probably know what a box joint is. It's just a bunch of fingers and sockets that are sized exactly the same size. So you put them together and, it kind of holds nice and tight. So the idea is, how do you create that? And basically it's just a sled with a pin. A simple one is a sled with a pin in it. And this one is built for a data set on a table saw. It's the same concept. If you have a router table, the jig is probably just a little bit smaller. This particular one, I have some plastic miter slot guides on it. You can get these at Peachtree Woodworking. They're kind of nice because they're already sized for your slots, and they don't expand and contract with the moisture. So I like those on any kind of sled that I make. This one, it's got a few adjustments on it. The first one is the main adjustment, slides the pin that's closest to the slot in and out. You can see it. And that's what you want to try to get you want to try to get the gap between where the blade is and this pin to be exactly the size, same size as the dado stack that you set in there. So the dado stack sets the width of the slots, and then this will control the width of the pins that go in there. And the second thing I've got is another, this is just a little right angle support bracket you could get at Home Depot, whatever. I just found them sitting around my shop. I figured it'd be a good use for this. So the idea is you cut one, and then as you move it over, I can move the other pin and tighten it down. So as you walk your piece across when you're cutting it, it always fits in there nice and tight, and you don't have to worry about it sliding. Strictly, you wouldn't need that as long as you always push it up against there tight, but this is just a little bit of extra insurance to hold it in place. The other adjustment is this block over here on the left, and that's only used when you're trying to get an accurate gap here. And the way that's used is I will first set it to be fairly close to what I want, and then make a test cut. And it probably won't fit real well. Let's see. The other side that I have here, you know, is nice and loose. Can't have a hard time doing it with one hand. Yeah. So yeah, that's not what you want. So what I do is after I get that, I take a caliper and I measure the slots, measure the pins, and take the difference of those two and figure out whether it needs to go larger or smaller, and by how much. And then I have a little feeler gauge. This is an old feeler gauge I had for setting spark plugs when I was a kid. But, and if you're not familiar with these, it's a bunch of different thickness metal with a size stamped on it. So you just add together whatever ones you want to make that difference. And that's the amount you want to change the gap. So you've got your pin locked down. I move this one up against it, and inside this pin, there's two screws that match up with each other. And this is a hard point for a reference. So if I want to move this pin to the left, to my left, I just put that in there with the feeler gauge, tighten it down, and then I can move the pin exactly that amount the other way. And then when I'm making my next test cut, it ought to be pretty much right on the size that you want. And that's pretty much all there is to it.
So your table saw has two miter.
It has two miter slots on it, yeah. Usually if you have a router table, you may only have one, but mine has two. Strictly speaking, you probably, could get by with one, but this makes it a little bit more solid. This one I made a little narrow. If I had to do it over again, I would probably make it a little bit longer, because it has a tendency to want to tip this way, and then you don't get a square cut.
Which is thickness that you cut is only small.
Yeah, you're only taking out, that much. So.
Did you figure this out yourself?
The basic idea of it, I saw on the internet. I first made a box joint jig that I saw on the internet that was just a board with a piece of wood that was the thickness that you wanted to make it glued in. And then with a slot in the back of it that you could attach to a miter guide. So I put it on my miter guide, and I actually, move it around. It's hard to get it adjusted. Once you get it, I actually made a box out of it. And it worked, but it was a little frustrating getting the size right. So I looked a little bit further and I got, somebody that had this size thing in there. The pin thing was something that I came up with, with the stuff I had sitting around the shops. There are lots of videos out there and you get all kinds of different complexities. So,
Thank you very much, Gene. Oh, Larry?
Well, I didn't know we was gonna show all of them, so, and, the same thing here. This is again from Woodsmith, is a figure joint jig. Now, you've seen the ones you do dovetails that you just use and run on the tape, router table. Well, this one is the same thing, except for it's for box joints. And these, you can make different sizes and you can have variable space. Oh, I'm sorry. You can have variable spaced box joints based on what width these are, and they're screwed down. And you just have a little screwdriver that you with a, whatever that 6-sided thing is that I bought, and just loosen them up and tighten them down where you want them. And then as far as the adjustment, somewhere here, where did I bring that? Oh, no, it's this end. This holds, this is the end you put your wood up against. And then this is your top first box joint. And that right there is a spacer so that you don't eat up in everything. And right here it says, do not forget your spacer. So anyway, so, but it just has a slide across the top that you bolt all these down, and but it works just like the dovetail jig. And again, it's a Woodsmith thing, and it works great. You can't make real small ones. This is for this 1/2 inch is probably the smallest you can go, because you have to have a washer down in there and for the bolt, the type of bolt that the screw that I used. But anyway, it's one of those jigs that they come up with every once in a while, and this one I do have the instructions for if anybody's interested. But anyway, just another box joint and a different way of doing it.
This is, I'm CC Kimball. This is simplicity itself, and it just excited me a lot when I found it. 2 pieces of wood. So you drill a couple of holes and a little space there. And it's for your table saw. It's called an L fence. Bob Van Dyke has some articles on that in Fine Woodworking magazine.
So you can be consistent. You can put like a stop block on a miter saw, so your cut is going to be the same over and over again. You can do anything like that. I know Charlie brought some stuff to show us about how to be repeatable on a lathe. So
Have a guy here? Full guy? No, I don't have, I can look at the grind and say, I like that grind in order to heat it. But
good. Yeah, I got it.
okay, so you notice I have a red mark here? And I got a red mark on my jig. So I color coded all my tools to, so I know which jig I want to use. And this one is, happens to be a Glen Lucas #4. It has a 55-degree bevel. It has a jig selection of 3 with a 2-inch projection. So I need to be able to adjust this to a jig selection 3. And then you count the notches here. The notches are fairly imprecise. So I've scribed a line on there, so I can go 3 lines down, line it up, and tighten it down. And I need a 2-inch projection, so I have a 2-inch hole in here, a little penny in the bottom so it doesn't wear. And I can put my gouge in here, just like this. now I have a 2-inch projection. And I got a jig setting 3. Take this over to my Wolverine system, which has an arm on it. This goes against the back, this goes against the thing, and then this goes against the wheel. And that sets my 55 degrees. And once that's all set up, it's like 10 seconds to sharpen your gouge. So
Sharpening the gouge for wood turning.
for wood turning gouge,
So you have because it's such a funky angle,
right,
you can make it consistently sharpen that particular weird angle
right.
on a spinning
So-
disc.
All my gouges that I sharpen this way have a color code, and I have a thing like this, so that I can set this up really quickly. Once it's set up, I can go from the lathe to sharpen and back to the lathe in 30 seconds. And that's what you need to do, because you need to sharpen a lot when you know. And the last thing is, if have a tool that I want to sharpen on the platform, and I want to find the angle, keep a consistent angle on the platform, I have this on the platform and this against the wheel. And that repeats my angle. And this is for scrapers, and one for other tools and other angles.
So if you're curious, there's a grinder set up over there that you probably can't see. But if on the way out, you can go look at that grinder, and that's got a Wolverine system below it.
Yeah, you just
So you
put that
can,
in the pocket there, and then you rotate it across the wheel. One thing I learned about these things though is that all of these jigs, all they do is they set the angle for you. They determine the angle of the wing and the length of the wing, but you really still have to control how you put across the wheel, because you can make it too pointed or not pointed enough. So it is a little practice there, but once you get that, it's like you're done in 30 seconds or less.
Charlie, diamond wheels to grind up.
Those are, I use CBN wheels, which are cubic boron nitrate.
Something like that, yeah.
Yeah. And they're they don't wear, you don't have to use the screw them up. And they're and you can get them in all kinds of grits from.
What grit do you like to use?
I like 180, what I should say, I like what I have. Wait, I have an 80 grit that I use if I want to take a lot of metal off. I'm typically using the 180. I also have a 600, which is, it heats up too much. I'm not quite sure if I like that so much. I just got that recently. If I had to do over again, I think I would buy a 350, but jury's out on that yet.
Yeah, they're not cheap. No, thank you very much, Charlie. Anybody have a jig example for what they've done to make something more consistent, more reliable, more repeatable? Yep.
I'm John Hofstadter. I didn't say my name before, so the way I made the wheels is just from a square piece of birch plywood. All you need is a hole, and this rides along your miter gauge track, and then it has to have a hole in the square board, and at the first you each take off the corner, and then you take off the corner, and you just keep going around on a bandsaw, and finally it makes wheels. And you can make them any size you want. So that's a very simple jig for making wheels. You want to make toys.
So your truck has the same size 4 wheels every time.
Well, I wanted 2 different. Different molds.
There you go. Anybody else? Oh, Mark does.
So being the cheap person that I am, and I've been for many years now, 20 years ago or so, some of you probably recognize what this is. 20 years ago or so, in my 30-year-old house, some of the, what's it called? Not the shutters. The shutters on my house started rotting off the walls, basically. So I decided to go ahead and make my own shutters, because I couldn't pay the $250 a pair at the time for house shutters. So what this is, let's see if I can hold this. Yeah, I would. Thank you. So what I did is I took two pieces of wood. So this is two pieces of wood that I've kind of butterflied together, sandwiched them together, flipped them, right? For those of you who are new to woodworking, one of the ways that you can make something consistent across two pieces is to cut them both at the same time. And so that's what I've done is I put these two together, lined along this line, drilled holes on either end, and then cut it with a jigsaw between the two holes. Okay. When I did that and I butterflied them back out again, now they're consistent. If you can consider the two pieces, the rails and the rails and the stiles, this is for the two stiles, and this is to cut the slats that go in between it. Okay. So it uses again, a bushing along a router, plunge router that goes in there 1/4 inch, that goes ahead and cuts the little mortises all up and down. And you'll notice that they're kind of gapped apart. So I didn't have, this is again 20 years ago, I didn't have a lot of great plastics and everything else to use. And I figured if I went ahead and tried to cut another piece here, another hole, they would run into each other and they would just start, well, you know, when I was trying to use it, it would just wander all over the place. So instead, I went ahead and butterflied these out, and glued them back together again, put two battens on it to hold it flat. And I've got little holes here, 1/4 inch holes. It's basically at the place where the next one would be. So the way that this works, this is kind of a fixture and a jig, right? So I take the two 2x4s or plane down that would fit exactly in that between the two fences, slide it along. I clamp the two pieces together and keep them clamped together. You'll notice that one end is longer than the other. I can go ahead now, slide this along, clamp it with that up against the 2x4. And then I can cut all 8 and then put a dowel in one of these, slide it along the 2x4s, the two stiles, until that dowel drops into the hole that I previously created. Now I can go ahead and make the next 8. And I can go all the way down the entire list, clamping on one end or the other, and go ahead and make both of the styles and all the absolute matching, perfectly matching places for all the slats to go in.
How many trials? Pretty cool. It's genius. How did you figure that out?
I saw something on the internet 10 years ago, but I've actually kind of had to figure it out. I mean, because, you know, you couldn't do this by yourself a long time ago. It was only commercially made. And again, I didn't want to have to pay hundreds and hundreds of dollars for that. So it was trial and error. This was made from scraps. So it just happened. Anyway.
And Gary brought a thin rip jig, which is really cool. The one that I do is much worse than that. Much worse.
Much worse. So it doesn't fit the consistency or the precision part of it.
Whatever multiple things.
Okay, so a lot of different manufacturers make thin rip jigs, but you probably pay $100 or more for them. So this is real simple, shop made jig that for the price of a couple of miter slot clamps and a couple of knobs, a little bit of woodworking.
Big Woodpeckers is on sale for $130.
130. I'll sell you this for, you know, it's sort of interesting, but the real advantage of this is that the edge of this comes right down and meets the table. So you can cut some very low profile, thin pieces. I mean, I've cut like a 32nd of an inch from the blade to the edge and fairly narrow height because it doesn't tuck under the wheel that some of these thin rip jigs have. So it just works really well. And
What is the piece that's
oh, it's just eyeball cut, you know, nothing special. Yeah, yeah. Mark's got it.
The way they work is you put the piece of wood against, you measure the tip to the blade, right?
Yeah,
That's how you decide, how thick it's gonna be.
right, and your piece of wood is up against the fence. So each time you slice a piece off between here and the blade, then you move the fence over so that the piece of wood hits this protrusion again, and then you just keep going through it. That,
So you
Does that
start
make
with the jig-
sense?
So you start with the jig next to the blade, so you can measure the distance. and
Right.
then you got the measurement, you lock it in, and you slide it backwards, so it's clear of the blade.
right,
And then you put your piece of wood up against it, push it through, move the fence, push it through, and you just get it over and over again, the same size piece. Of Works great. And for $130, you can get one for woodpeckers. Works almost as good as this one. Thank you very much. Theirs is aluminum. The other thing I just put up here, just to point out that it doesn't all have to be handmade. Everybody's heard of a Craig jig. I mean, it's right there in the name. You want to do something consistent, you can do pocket holes, and Craig or all the other Castle and et cetera will make them. You can buy dovetail jig. We've seen those. Brent has even sold a few, which cost him some hairs probably off his head. And they're expensive and big, and they make really repeatable, consistent dovetails if you want to make lots of drawers over and over and over again without doing it by hand. Safety, you can also, the other thing jigs do for you is they add a level of safety. I think, was this Gene who brought the ship, sent me the tenon? Or was that Gary? Did you do the tenon?
I have one.
I think that was from you. Okay, it was not. Well, would you mind talking about it anywhere? Did somebody else bring one? No? Okay.
Talk about the one I made.
So this one has the benefit of keeping your fingers away from the blade when you're trying to do a weird cut.
Yeah. So,
I'll hold this. Go ahead, I'll hold it.
okay, so the objective here is to cut tenons in the end of a.
Can you hold it up a little bit, Gary?
Yeah, so I want to cut a tenon at the edge of this. This fits over your fence, so it has to be fitted to your fence. And then set your blade so that you're trying to achieve the distance from the edge of the piece of wood to the edge of the tenon. So that's the dimension you want from here to the blade. You want to make it a little fat, or actually you want to make it thin so you can sneak up on the tenon as you adjust it. Keep flipping it back and forth. And so this will fit on here, and you can take a clamp, a bar clamp or whatever, and hold it against the jig. And you just go back and forth and slice it. So pretty simple, and it's nice to have a good dimension along this length so you don't get any wobble as you go through it. But again, it's real simple to make.
Thank you. And I remember now it was Tim Settle that sent me this. He couldn't make it tonight. But thank you for sending that. Anybody bring an example of how a jig can help you with safety? Jim does.
Show you something about the change you can make in this jig.
Jim?
This is
Jim?
made by, sorry.
Jim, that jig is perfect.
Suppose the piece you want to make a tenon in
Jim?
is 45 degrees. This is 90 degrees, okay? Hold it. This cuts a tenon in the end of this. Suppose it's 45 degrees or 30 degrees. Move the fence. Screw on another fence or make another one of these. But you can also cut a tenon in a piece of plywood this long if you make this bigger. So, and I would suggest making it out of this, they sell it out here. It has a plastic laminate surface on it. It's very expensive, but you don't need much of it. It'll last forever, and it's just as slick as it can be, which is what you really want, because this has to slide, and make it as tight as you can get to your fence and wax the inside of it. Because it needs to slide without hiccups.
Mark mentioned you could mount a toggle clamp up on the base of that.
Yeah, yeah. There are a lot of things you can do to make this more versatile.
Any other improvements to Gary's jig while we're at it?
There's two back here.
I can talk about that. Tom McLaughlin on his website, excuse me, I'm sorry, that's fine.
Martin,
Has-
you wanna bring them?
Tom McLaughlin has a variation on that where he takes and it's wider at where you put your piece of wood up to. And when he cuts, he sets it up where he wants where he wants it to be. But then he has another piece of wood that goes behind that pushes it out to where you want to cut the second one. So you don't have to flip them around and all that. And he makes fine adjustments for that when he's making one with just tape. And it works great as far as that. And it's a bigger version of that, but it works very well. And I'll let you have it.
Let you hold the mic.
I will. Okay.
Along the lines of what he was speaking of is if you don't want to always have a 90, this one is modified so there allows you to have an arc of whatever degree you have a need for. While we're talking about this, if you want to use it for, I needed to also do spline joints or cut splines. So this is held on with knobs. I can take it off. And on the face where the vertical is, this gets screwed onto the face and it can then cut a spline of whichever dimension.
Just in case anybody didn't get that, would you mind holding that last piece up again to show the wood where the slot is, where the wood would go?
So you got a drawer, you put this big old drawer in this hopper.
So the corner's down there at the bottom.
So the corner's at the bottom. It's screwed onto the face of that traveling tenon shape. And just with a couple of fasteners, it can be attached and converted and set aside.
Cool, thank you.
Hey, I misspoke about that phenolic colored plywood. They used to have it, but I just learned it's been discontinued here. I don't know where to get it now.
Woodpeckers.
For 260.
That's right, on sale this week. Versatility. So now we get to the CC's L fence. So the other thing, so the L fence I put in versatility because you can do tons of things with it. John Champion provided this picture. And the one on the left was one I found online, and the one on the right is the one that John sent me. And CC's brought an example of it. So I think we have two people that can talk about the value of the L fence. You want to go first, CC?
You can do that amazing on the tabletop, but basically all you do is you're taking this and you discard against the fence of the clamps to hold it on. And then you adjust the height of it depending on what you're trying to cut. And what you do is you bring up your blade just almost to it. 32nd of an inch, almost up, but the blade is actually underneath. But then you can take your piece of wood and you can clamp the straight edge. All you're trying to do is then take off a little tiny piece, and tiny pieces that don't want to get trapped. Anything. This gives you space between the piece and your fence. So you got your piece of wood, you clamp on a guide basically, and just run it along there, and that's all that little tiny piece goes away. It's like it's not gonna kick back at you. You can do any number of things, including like, I like to think of it really about sort of a pattern jig. You think about it, because you can take, if you want to do tapered leg. So you take a piece of wood and put it on your workpiece at an angle, and you just slide it right under here, and it takes off what you want. Okay? And I got all those things. I brought, just a simple version that Bob Van Dyke made about 10 years ago. He's got a new one out, now it's got all the adjustable things. And it's not any different, it's just a bigger. That's all you have to do is move this up and down and on your fence and clamp it in at whatever height you need. It's fine. It's easy. I was trying to figure out how to get some little narrow pieces off and especially if you have a piece of wood, what you're trying to do is maybe straighten the edge. The edge of your wood is wavy and you don't have another way of straightening it. You can make, if you go with a straight edge, put it on there, you can screw it on, you can decide to tape it on, whatever. And then you run along there, you straighten out the edge of that piece of wood, now you got a straight edge. There's so many things and so simple that I got really excited about it. And I thought, well, you guys probably have been around for a while. Nobody knows. I said, but you're new to it, you probably don't. So anyway, I think it's great. And there's any number of things. So maybe you'll talk about more.
No, I'm gonna let John talk.
You can you can do rabbits. You can do actual patterns, all kinds of stuff. Exactly.
Bob, Bob's last name?
Van Dyke.
Van Dyke, yeah, Bob Van Dyke.
Yeah, Bob.
Great article. You've done a couple of times. I've referenced you to that article. I just want to emphasize something she was just saying, Tisha was just saying. I think the slickest thing this is used for is, it's hard to see in the picture. The one on the right is sitting about a couple of inches high. So if I wanted to draw any angle across this board, I'm arbitrarily draw a straight line from here to here, and that's the line I want to cut. It was always a challenge trying to, how do you cut that straight line? And all I have to do, this whole fence, is set the fence just slightly higher than the piece I want to cut so that it will slide under the edge of it. I have another piece of wood that I just have a piece of sandpaper on, line it up on that line, and the sandpaper alone holds it. And you hold that up against the edge, which is higher than the piece you're cutting, and just push it through. No clamping. It's just about the simplest thing in the world. And you can cut any straight line at any angle you choose. It's just the slickest thing, I think, in the world. And as Cece said, there's many, many ways you can use this tool. It's a great tool.
I couldn't remember.
I've done the same thing. There's a lot of things you can do with it.
So this is a good point to mention. Some of the stuff that's in the presentation, I made a reference page. So I got a bunch of these that I'll just have the links. So just feel free to grab one on your way out. One of them is the article that John used to build his L fence from Fine Woodworking from 2021. So it's a full URL to get to that page if you'd like to go find it. Anybody have any other jigs? I think we're getting ready to do handmade tools. So yes.
The only guy in here who doesn't have a table saw. I made this jig for doing segmented bowls like the one I brought in. This is extra heavy duty. And I did it so I only have one because I drilled multiple holes. But I have these bandy clamps, and they're the hose clamps or whatever. You can't find them any bigger than about 4 inches in a Home Depot or Granger or any of that stuff. But on Amazon, you can get a do-it-yourself hose clamp in 12-foot lengths with 8 screw-on clips for $12. It's a pretty good deal. So I made a bunch of varying sizes, and that's how I clamp my wedges, the little segments together. And then I sit it inside this. I clamp this down. This is 3/4 inch Baltic birch plywood. I drilled 2 holes and I squared it out. If you look at it, I have circles with an inch out, so it's every 2 inches. So I can do a 6, 8, 10, 12 inch, and I can move the clamp part out for the bigger bowls, move it in for the smaller bowls. Most important part, these little washers. When you clamp down, So then you can actually take this nut and go right through the wood if you're not careful, but it was pretty efficient. These are 12-inch threaded rods, 3/8 inch diameter. You can buy them at Home Depot for less than $2 a piece. And these little nuts I found that are 1.5 that hold it up off the table. I put this on top of a silicon mat, and so it doesn't move at all when I set it down. And then I tighten these down with a box wrench as tight as I can get it, torqued to the point where it won't move anymore. And the glue just comes squeezing out. So these are waxed on both sides, but I don't trust that. So I put wax paper underneath them too. Because I don't want to damage this, because if it becomes uneven, then it may mean that the pieces don't line up exactly flat. I made this 2 weeks ago. I made 2 bowls already. That's the second one. I finished that one last night. You put this in there. I did that Sunday. I squeezed it all down and let it sit for 24 hours to make sure the glue had cured, and then I put it on the lathe. But it's the only way you can clamp both ways, both directions, because you have to clamp both directions, because if it doesn't lay perfectly flat, or the angles of your wedges is extremely important, because if they don't fit exactly and you have a gap, you're going to have a hole, and as you're turning it, it may fly away from you all over the place. So got to make sure they're all touching on both sides and everything's square. But when you use these little hose clamps, you can get that down really, really, really tight too, more than a bandy clamp or a cloth one. They get tight, and I can make mine any length. My next project's going to be a 12-inch, 12-segment bowl, which is a lot more wood and a lot more work and a lot more time. But in the process of doing that, I'm going to have to pyramid the various rings together, and they're not going to be the same size, or else I won't be able to curve the bowl. So you can do it with this. There's nothing else you can do it. And if you have the top ring as your top piece, there's no solid, nothing to clamp it to except for something like this. Question? Yeah. Miter saw. I have a angle block that I got from a competing store to make sure that the miter angle is exact. And so I do that. And like if you do 12, each angle has to be 15 degrees. This 8 is 22.5. It's pretty simple, and you can figure out any number of things. Just make sure that all your cuts add up to 360, and you're just fine.
I hope this is on. This is about precision and versatility and safety and everything else. This is a sled I used on my router table, and I use it. I was making these boxes that go in that octagonal box over there, and it's pretty thin. It's only 1/8 of an inch thin, and this happens to be for 1/8 of an inch, but you could use this for any size or dimension you have. But I wanted, I thought this was going. I was concerned about this not being a strong enough joint if I just put glue on those. And I think I've came to that conclusion because I made one and popped it hard and it broke apart. So I decided to put splines in here, but it's pretty small, and I didn't want the splines to show through the top, so I wanted blind splines. So that meant, can you see this? That meant you needed to have a slot cut in the end of this, and you need to have little splines that would fit in the slot. So to cut those, I made this little sled. I can adjust it back and forth for thicker material. So if I had a 3/4 inch side, I want to put a blind spline, I could do so. This is set at 22.5 degrees, which is the angle for the octagonal box. And I use a 1/16 inch bit on my router table. Again, it just happens to be a small version of this, but all I have to do is slide this in here. I have a couple of pieces of tape marking on my table to tell me where to start. Put it down, slide it over, turn off the machine, pick it up, and it's done. It takes seconds to do it. And the thing that struck me more than anything about it, not only did it get done what I wanted to get done, but how safe it was and easy it was. My hands are way up here. If this thing blows up on me, and it's got enough weight to it, it's not gonna blow up on you. But just a very handy device that solved my need.
So the next step, what we have left to talk about is handmade tools. I've seen a few people brought in some handmade tools. I just want to talk quickly because Doug couldn't make it. If you go to the next slide. Doug Piesig sent me pictures of these micro chisels on the left, and he just thought it was a great idea. He just took some old Allen wrenches, and everybody's got old Allen wrenches, and he just basically ground the whatever angle he needed with the size wedge Allen wrench he needed, put him in a handle, and Charlie or any of these guys can tell you how to turn a handle on a lathe, and made himself some very fine micro chisels for doing small work. That was great. John brought in these two, or sent these pictures. They're just simple, very quick tools.
So as I've gotten older, my hands have gotten a lot weaker, right? I have, for me, at my advanced age, I have a difficult time pulling the top off this bottle.
It's not just you.
Okay. So I made this little device to do that. And I get lots of leverage. About 9 months after I made this and thought, gee, isn't that clever? I saw it in fine woodwork, and some other guy had made one too.
You can buy it at Woodpecker.
Well, you can buy it at Woodpecker for $130. I should have. I just thought that was peculiar. But the other thing I bought in, I have a rigid this thing, the glue trick. Okay, you ready? Here we go. You get that? That's what it is. It's repeatable and it's efficient. This is this happens to be maple with smeared glue on it. That's what it is. Straight grain maple too. My other problem, and this was my bigger hand problem, is I have a rigid spindle sander. I love the machines, great little machine, relatively inexpensive. It does all kinds of wonderful work. And for those of you who have them, you have these little spindle pieces, and it has a little washer piece on top, and you screw in this little knob piece on the top of it that puts pressure on the rubber center here, which keeps the sleeve on. And I got a couple that you have to really crank that thing down to keep the sleeve on it. Well, I get it down, and that's great. Now I can't get it off. I don't have the strength to get this thing off anymore. And actually, that's where I got in trouble. I used a nice big wrench, and you see the end of that? I just chewed the end of this thing. It's just a little rubber cover on a plastic base. And I thought, well, that's great. It just destroyed my little knurl knob. So I bought a new one of these so I'd have a nice knob. But then I saw this on the internet and I made one of these. And you drill, I think I drilled maybe 4 or 5 holes and then just some files, filed it out, and it fits on this knurled knob. And I'll tell you, it works like a charm. It works about as easy as that glue puller. So whenever I have to undo this now, I just go crank and it doesn't tear up the knob and it's done. And it caught. That's right. So this again is a nice piece of face grain maple, but there's no finish on this. I did sand the edges up. So. Well, I would do that, except I keep this with my rigid machine and my glue is on the other side of my shop over there. So.
That tool is $229 from Woodpecker.
That's right. You're asking way too much.
It's been my woodworking idol for years. Paul Sellers, he has a kit. The hardware is the only thing that comes in his kit, and directions on how to make this. But it's a router plane. And it comes pretty sharp, but it wouldn't hurt if you sharpened it yourself. and it comes with a set of plans. This is red oak, Hobby Lobby knobs. Okay, cheap dollar knobs that work fine. The trick to this is getting the correct angle for the blade itself, but it is adjustable. You can loosen these knobs here and adjust this up and down, and it works like a charm. I did red oak on this, and when the first iteration of it was I had the grain running crossways, and as I was going this way, it caught and ripped. So I ripped about a half inch off of here and put hard maple with the grain running in the direction of the motion, and it works really great. This is I think $42 for the kit, and it comes pretty rustic, so I put it on a buffer and cleaned it up so it looks a little more professional, but it really works nice. And you can buy used router planes for $40, $50, so there's no sense in building this, but the fun of it is I made it, right? And that's, to me, what we're all doing this for, isn't it? I made it. And you don't need any personal reward from anyone else, as long as you can look at it and say, I made it. That's the joy of all this. Thank you very much. Yeah, Paul Sellers will deliver it to you postpaid. It comes to your home, and I think several of us in here have probably bought the kit already. I don't know if we've completed them yet or not, but we've bought the kit.
Brent?
Next.
So Brent brought some tools. He's gonna come over there so you can.
Yeah, I brought several items here. Two of basically the same thing. You can buy this mallet or you can make one. The unique thing about this, and I'll defy anybody to name the type of wood. This is actually mountain laurel. And I have seen mountain laurel chip concrete. It's one of the densest and hardest materials known to man. Walnut handle, obviously. But the mountain laurel is extremely dense, very heavy, and it's nearly impossible to split. But two different mallets. I call this one Mr. Encouragement. But it's pretty easy. Made a walnut handle and put in wedges, wedged it in both directions. I made these about 15 to 20 years ago, and they've held up pretty reasonably. Most of you know that I'm also pretty big fan of metallic planes, but also like wooden planes. And this is one like Bob was just sharing that I actually made. I started with a big block of wood. It is a commercially available blade and chip breaker, but all the other pieces were fabricated, including the brass and turning of the handle and knurling of the brass knob. It's nice to have friends that are very capable in metalworking to let you use their tools. But it even has the knob for adjusting the blade. As you can tell, made this one quite a while back as well, and it wasn't as careful as I should have been, and so the mouth is much bigger than it needed to be. But you can still make some pretty fine shavings. I can get a shaving down to about 3/1000 with this plane. So you can buy tools or you can make your own tools.
Is there anyone here that does
Right there. Not so close.
chair recating chair seats beside me?
Somebody shaking their head back here.
Yep, one back, one in the back. Go for it.
Okay, getting back to John with the Allen wrenches. What's the hardest part of doing that? Getting the old spline out. I took an Allen wrench and took a piece of UHMW, drilled a hole in the block of UHMW, and I ground a point on the Allen wrench like a chisel. You can put it down in the spline groove at any depth, tap the Allen wrench, and it acts like a chisel and knocks all that crap out.
Cool. Awesome. Great example of a handmade tool. All right, so that's all that I have for the presentation. We've got some time left. Does anybody have any questions or comments about what else, about this stuff? Oh,
I do a lot of CNC work. And most of these jigs, I notice that they move the
hold
wood.
on. Zoom people would like to hear what you're saying.
Sorry. I'm just saying this, yeah, if you want to, Roger, Dodger.
There you go.
Yeah, I know that, that in most of this, jigs and all, that you move the wood. And when you're doing CNC, you generally have the wood stable. And what you want to find is things that are repeatable. And so I do a lot of things that I repeat. And I found that pneumatics is just fantastic. I don't know if anybody gets involved in pneumatics, but you know, you hook a pneumatic pistons with a foot switch. It's real inexpensive, easy to do. We all have shop air. And you can use it for a couple of things. One is to push items into a square to hold them tight, and the other one is to press it down, because one thing you need on CNC is you got to have that you know, your wood really stable, otherwise you know, the bit will pull it out. Anyway, I was just saying that you know, for those that haven't looked at pneumatics, it's simple, it's inexpensive, and boy, those things. And also for clamping, if you're doing a lot of wood, you know, clamping, like making charcuterie boards or whatever, you know, if you put a line of pistons and you can just crank up the pressure or whatever you want, it saves you from having to crank them all down. Anyway, that's all I got. Thanks.
Two forward. You have one.
I just had a quick question, for making jigs. I think the one gentleman mentioned what he made it out of, but I see a lot of similar pieces of plywood. What would you say is the best wood to make a jig out of?
I don't think there is a best wood. I think it really matters. It depends on what you're trying to do. If you're trying to do something you're going to use one time, it doesn't make any difference.
Right.
Even if you're going to use it thousands of times, if it's not going to come in contact with stuff, it doesn't make any difference. So if you want it to be pretty, make it
I'm
out of
thinking
something
about
nice.
like strength and.
Yeah, it
square.
really depends on the use case. If it needs to be strong, you want to use a stronger wood, oak or maple or something. Like for example, Jim used maple for the winding sticks because he wants them to stay stable and consistent for a long period of time. So he used a real strong, dense wood. You wouldn't necessarily want to use pine because who knows what that's going to do over the course of a year.
In terms of strength, if you're gonna squeeze it or move it around like on that clamp, you have to use plywood, because if you use a board with straight grain, you're gonna crack it in half. So you sort of need to pick what you're gonna use it for and how it's gonna be applied.
And you also have to worry about the jig doing something to the material. So you might not want to use something super hard because maybe it will dent or compress the material you're holding it against.
MDF is good for the first iteration.
Yeah, MDF is great for, you can do lots of the CAD design, cardboard aided design is another one that I've heard.
I'll give you another answer. Baltic birch plywood comes in 1/4 inch, up to 3/4. Maybe there are other sizes, but you can always count on it being tough, smooth surface, flat.
Consistent.
and- Yeah.
Milton's got a comment. Oh, he's got a jig or something. Milton's got something.
Wasn't finished.
Oh, I'm sorry. How did?
You can come back. Okay, so the question is, have you ever tried to drill a hole through a ball?
A hole through a
A
ball.
hole through a ball and have it in the center of the ball?
There you go, right there.
Well, you bought that.
Oh, I didn't have any holes in it. Come on.
Okay, so here's the simplest jig of the night. Take a square piece of wood, Forstner bit, slightly smaller than the ball you're trying to drill a hole through. It gives you an automatic center point. So when you put it on your drill press table and you can lower the bit and center it right on that point that's already on there. And then when you put the ball on there, when you come down with your final drill, it's going to be exactly in the center and straight through the middle. So there's another one.
You just
Yeah.
have to have a
You-
way of clamping that ball. so
You,
it doesn't
you can,
spin.
yeah, you can clamp it in a wooden vise thing.
One of those up there over Martin's left shoulder.
Yeah. What do you call those? Screw clamps.
Yeah, screw clamps.
Screw clamp. Yeah.
Now can Milton talk?
Here's Milton. I'm sure this is going to be really important.
So I like your idea so well on the glue bottle that I have this I have 2 Rikon benzones. 13, 14 and a 10. And I particularly find the lower ones are hard to get open without a pair of pliers. You just take a piece of hardwood, take the bandsaw, cut a slot just to fit the knob, and then put a magnet on it, stick it right on your bandsaw, and it's right there when you need it. You don't have, if you get it, if somebody tight, too tight, you can't get it open. Just pops it, pops it.
Awesome. Thank you very much. Anybody else have anything? All right, then I guess that we've wrapped it up in a pretty good time. So I'll hand it over to Martin to do our final thoughts. Thank you, everybody.
Thank you. What a great presentation. Robert.